Let's begin with the last last question from the sprint round. Let f of x be a degree 3 polynomial such that f of x equals 1 over x squared for positive integers x between 1 and 4 inclusive. Compute f of 5. Okay. So we see that, okay, these points are represented by a function, f of x equals 1/2. And when you plug them in, you'll generate points that will lie on this particular curve, general curve f of x. And so we can see that, okay, we're trying to find these values of x. We basically have to simplify, solve this equation. But we're going to let g of x be as such, x squared times f of x minus 1. But note that the types of points that are now lying on the polynomial, we all set that down to 0. And so those values of x now are the roots of the polynomial for g of x. So this equals 0. This also equals, okay, some constant a, because this can be scaled up and the roots don't move anywhere. 0 times a constant is 0. Times x minus 1, times x minus 2, times x minus 3, times x minus 4. But we're not done yet, because here, f of x is a degree 3 polynomial. We just multiplied by x squared to it. So now it becomes a degree 5 polynomial, but on this side, it needs to also be a degree 5 polynomial, so we have an extra root. Let's name that root r. Realize that now the x term doesn't exist. And so we see that in order to find the x term, we see that we're just multiplying any 4 of these roots together. And so we see that, okay, we get a times, convert the constant times, okay, roots are 1 times 2 times 3 times 4 plus 1 times 2 times 3 times r plus 1 times 2 times 4 times r plus 1 times 3 times 4 times r plus 2 times 3 times 4 times r. That needs to be 0. Okay, we can divide a out. And so we see you get 24 plus 6r plus 8r plus 12r plus 24r. That equals 24 plus, this is 14, 36r, 24 plus 50r, that's 0. So r is minus 24 over 50. Simplify that to 12 over 25. Note that also our constant term, 1, negative 1, is equal to the product of the constant term on the other side as well. That's just a times, okay, negative 1 times negative 2 times negative 3 times negative 4 times negative r. And so that gives us, okay, there are 5 negatives, so it's still negative. 24ar, that is negative 1. And so a is 1 over 24r. And that r is negative 12 over 25, so that is 25 over 24 by 12. And that is negative 25 over 288. So now we can just straight up find g of 5. And then we can just straight up find f of 5 from there. So g of 5 equals 25 f of 5 minus 1. And that equals negative 25 over 288 times, okay, 4 by 3 by 2 by 1 by 5 plus 12 over 25. We see that, okay, 220 and 24 cancel down to 12 here. And so we see 25, we'll simplify it somewhere else. 25 f of 5 minus 1 equals negative 25 over 12 times something over 25. That is 137. So we see that 25 f of 5 minus 1 is minus 137 over 12. 25 f of 5 equals negative 125 over 12. And f of 5 is negative 5 over 12. This is answer choice D. And we're done.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.